Bismillahirrahmanirrahim. Today our topic is high voltage AC generation. So there are many methods to generate the AC. So we will discuss two of them in today's class and one in the next class, inshallah. So the first method is cascaded transformer. So as you can uh, see, this is these are the transformers. Transformer 1, transformer 2, and transformer 3, and these three are connected in cascaded form, so that is why it is called cascaded transformer. Okay, so how it will generate the high AC voltage, HVAC? So let's discuss it. HVAC. Okay, so here is a first transformer. So you can see that it's a primary winding and it's a secondary winding. Okay, and these are the tertiary winding. These are only used uh, to generate high voltage or to step up the voltage up to high value. Okay, so this is the tertiary winding. Okay, so uh, let's suppose we are getting V voltage from the secondary side of this transformer T1. Okay. Okay, so now this V voltage will be given to the second transformer. Okay, now this tertiary transformer, the tertiary transformer of transformer tertiary winding of the transformer T1 acts as a primary winding for the second transformer. Okay, so now this is the primary winding. Okay, and these are connected to the tertiary winding of the first transformer. So now the tertiary winding of the first transformer acts as a primary winding for the second transformer, and we will maintain the V voltage over here as well. Okay, we won't allow this voltage to be grounded. So that is why for this purpose we will uh, placed some insulator over here. Okay, so that the V voltage that has been uh, obtained from the secondary winding of the transformer T1 will not be lost. Okay, so we will keep it and we will maintain it up till the end of this cascaded transformer. So now again we have the primary winding, the secondary winding, and the tertiary winding. Okay, so the winding are selected in such a way that we will get double 2V on the secondary side of this second transformer. Okay, so for example we have 220 volt over here, and we will get 220 kV. This is the 220 volts and these are the 220 kilovolt. Okay, so this is step up transformer, that is why we will get the high voltage on the secondary side. Okay, so now if for example this is uh, again 200 volt, so how much voltage will be maintained over here? 220 minus 220 kV minus 220 volts, so it will be like 2 1 9 point something. Okay, so we will maintain this voltage over here. So again we will get 2V means 2 multiplied by 2 of this voltage. Okay, so now this voltage is double of the voltage we obtained over here. So it means the voltage has been enhanced more, has been enhanced further. Okay, so again we will apply the same procedure in the third transformer as well. The tertiary of the secondary winding will act as the primary winding for the transformer 3. Okay, and we will have the secondary winding of this transformer 3. No need to have the tertiary winding because there is no transformer after this transformer 3, so there is no need to have the winding of tertiary for this transformer. So simple, primary and secondary. Okay, and now you can see we have maintained this voltage over here by installing an insulator over here, so that this voltage may not be lost, may not be grounded. Okay, so again we have, if for example this is 20 volts. Okay, so if this total is 220 kV, so this will be minus from this, so that is why I have written 219 point something. Okay, so again uh, a step up transformer. Okay, so we will get 3 volt over here. So by this way we have obtained a high AC voltage. Okay, now the question arises that why we have followed this cascade transformer, why we have used the different units, the small units, to get the high voltage. Why don't we used a single unit instead of these cascaded units? Okay, so the answer is simple. First of all, for example, if a fault occur in a transformer, so if we have a single unit of the transformer, so it means the whole system will be disturbed, because the whole generation is dependent on the single unit and we have only this single unit. So if the fault occurs in that single unit, so what will happen, the whole system will be stopped. And if we have a different units, for example if we have 3 units and a fault occur in a single transformer, so uh, we are left with 2 transformers, the two okay transformers, okay, that are functional. So we will affect, for example we are affected one third. Okay, and similarly if the fault is in the fault is so severe that it cannot be repairable, it means we have to dismantle it and we have to dump it, we have to remove it from the lab. So we will have a loss of, in this case we have a loss of one third loss. Okay, but if we have a single unit, so uh, the loss will be a huge amount of loss, because this was a single unit and it is not repairable, we have to remove it. So we have to again install that huge big unit of the transformer. Okay, so this method is economical. Okay, and transportation, second is, the first one was economical. Okay, easy to repair. uh, the third one is, and the third one is easy to transportation. Okay, if you want to uh, install it for the first time, so single unit, to carry a single unit is easy. Okay, uh, from the weight and the size point of view. Okay, and if we have a bulky single unit, so its transportation and its carrying and its moving from one place to another is, will be a big problem. Okay, so this is also a point, this is also advantage of using different units for the cascade transformer. I hope you will understand it. Okay, so now move to the second slide. Okay, when the test voltage requirements are less than 300 kV, a single transformer can be used for the test purpose. For the higher voltage requirements, for example, means greater than 300 kV, a single unit construction becomes difficult and costly due to insulation problem. And the transportation, I have already discussed these points. Okay, the cost point of view, the transportation and assembly of large transformer become difficult. Okay, assembling is also a difficult point. So this one is the fourth point. And these drawbacks are overcome by the cascading, means in connecting the transformer in series of several identical units. So the fourth advantage is that if we design one unit, okay, so then we will replicate it for the other units. So there will be no need to design other units. So that is why we will use the several identical units. uh, for design point of view, we will design with the single unit and then we will replicate it. We will use the replica of the one design, the original design unit. Okay. Move on to the next slide. Okay, it consists of the high voltage and low voltage winding, as I have shown. The low voltage winding and the secondary, these are the right sides are the high voltage winding. Meter winding to measure the output voltage. Okay. Okay, so there must be some connection, okay, to measure the output voltage. Okay. uh, Circuit configuration: first transformer T1 is at ground potential, second transformer T2 is kept on insulator. I have already told you that we have to maintain the voltage we have we got in the secondary side of the T1. So for this purpose we have to kept it on the insulator and maintain a potential of V2, that is the output voltage of the first unit above the ground. And the high voltage winding of the T1 is connected to the tank of T2. Okay, and the low voltage winding of T2 is supplied from the excitation winding of T1. Okay, so these tertiary winding are actually the excitation. Okay, the excitation winding for the transformers. Okay, the low voltage winding of the T2 is supplied by from the excitation winding of the T1. Okay, the excitation winding of T1 is in series with the high voltage winding of the T1 at its high voltage end. Okay, these are in series. Look, the tertiary winding and primary. So this is also called the excitation winding. Okay, for rating of excitation winding is almost identical to that of the primary winding or of the low voltage winding. Okay, these are identical. The tertiary winding, or we can call it the excitation winding, are identical to these primary winding. Okay, and these are in series, so the voltage over here will be same over here. So from the example I have explained that we have, for example, 220 volt on this side. Okay, the rating of the excitation winding is almost identical to that of the primary or the low voltage winding. The high voltage connection from the T1 and the excitation winding terminal are taken to T2 through a bushing. Okay, bushing will be used in a similar manner. The third transformer T3 is kept on the insulator above the ground at a potential of 2V2 and is supplied likewise from the T2. Supplied likewise means we have again used the excitation winding of this side of the transformer as a primary for the third transformer. Okay, we will connect the primary winding of this with the excitation winding to get the same voltage Okay, so and again we have to place it on the insulator so that the voltage we got in the secondary side of the transformer 2 may be maintained over here. Okay, so we will get V, so this is 2V, so V plus 2V will be 3V. Okay, we have obtained V over here. So okay, so this is V, and we obtained V same as we got over here, V plus V 2V, 2V plus V 3V. So that is actually the summation. Okay, so that is why for this purpose the installation of the insulator must be necessary, is mandatory. Okay. The number of stages in this type of the arrangement are usually two or four, but very often three stages are adopted to facilitate a three-phase operation so that 3V2 can be obtained. V2 is actually the denotation for the voltage we obtain on the secondary side. V1 is the voltage for the primary side. V2 is the voltage for the secondary side. So okay, so 3V2 means V2 plus V2 plus V2. Okay, in figure, a second scheme for providing the excitation to the second and the third stage is shown. Okay, okay, now disadvantages of the scheme. We have explained uh, the advantages. Now the disadvantages: expensive and require more space. Okay, so look, if we have a single unit, so definitely the size requirement for that single unit will be less. Okay, so and the cooling, okay, the cooling problem will be solved. But now we have uh, the we have three units. Okay, so the cooling requirement will also be increased in this case. Okay, and the space requirement will also be increased. So expensive and require more space. Okay, the advantage of this scheme is that natural cooling is sufficient. Okay, natural, because already these units will be placed in a space, so a spacious uh, place is required for cascaded units. That is a disadvantage, but on the other hand, if there is a space between these units, so the natural cooling will be enough. Okay, means there is no need to use the oil or some fans for the cooling purpose. Okay, so the space will actually allow the air to pass through it and flowing from here and there. Okay, so this will be no need to be no need of the cooling required for this cascaded transformer. Okay, the transportation are light and compact. Okay, because now a single unit is divided in three identical units, so definitely the size will be reduced, and it will be a lightweight. Okay, transportation is easy. Okay, and assembling is easy. Okay, to make connections, and the construction is identical for isolating transformer and HV cascade units. I have already told you that cascade, these are called the cascaded transformer because these are connected in series. Means uh, this is actually, for example, this is a unit 1. Okay, this is a unit 2, and this is a unit 3. Okay, so these are actually connected by this way. So that is why these are called the cascaded units. Okay, and then if we have one unit instead of this, okay, one unit, so space requirement will be less, but the transportation the cost, the fault, and the cooling. Okay, this will be problematic for the single unit. Okay, so that is why this the scientists have preferred the cascaded unit. Okay, although the output of these, for example, this is 3V, so the output of this will also be a 3V for the same winding. Okay, but uh, but this is actually divided in the three units to get to be more uh, beneficial and advantages. Okay, so I hope you will understand this topic. Okay, in the second lecture we will discuss the another method of the transformer, the AC generation, that is the series resonance circuit. Okay, thank you.